Hey everyone, I am in my backyard right now. The lighting's a little bad, but it's such a nice night out, so I thought I would record here. Um, Also, I lost my voice. This is a very natural thing for me. I don't think you guys have actually heard my normal voice since we started, but I'm going to talk about lesson 1.3, which is the International System of Units. This is technically part 2 because we did part 1 in class, so let's get started. The International System of Units. I think that most of us know what a unit is, and we've been told the importance of putting units after our numbers, but we're going to go ahead and do what's called a review. So I want you guys to know and be familiar with the standards for making comparing measurements using the International System of Units. Sometimes this is called the metric system. I'll talk a little bit about that in a second. And we want to be able to do this for a lot of measurements, such as mass, distance, volume, temperature, time, and density. Okay. I'm going to go through each of these, what each of these mean, how we're going to use it in class, and what the standard unit is. And I'm going to make this very clear. You need to know this. You need to be able to talk using these standards and these units. And for every assessment or every assignment that we have, I'm going to expect that you present your unit in terms of what the International System of Units says that unit needs to be. So a unit, it's funny, I like to give definitions. Units are a standard for conducting measurements and comparing measurements, okay? They're usually an extra detail added to a number to give further context. Specifically, like I am 5 foot 6 inches. Foot, inches, those are units. Or, my backyard is 1 acre. So this is, why we make units. We want to say, I wouldn't say like my backyard is 1. What does that mean? We have to give context to it. And remember, these are not only written when you write things out, you have to talk about them as well. So when we're having conversations about data, we're having conversations about numbers or science, we want to make sure that we're saying the units as well. Why is this important? Well, units are globally recognized and they're necessary for sharing information between scientists in our classroom and around the world. If we want to communicate with students who are living in Asia or Europe or Africa or Australia or South America, maybe in Antarctica, I think I named all the continents. We want to be able to have that sort of language that we all mutually understand. And, this is really important to me as a scientist or former scientist, a current teacher. And it should be really important to you as well. When I was in college, this is a story, I was doing research with my professor and we wrote this 30-page article about the research that we found and why it was so important. And we missed a unit after a number, like when in like page 18, I'll never forget, page 18, paragraph 2. And the article got sent back to us because we forgot that unit, and it took another 6 months for it to be recognized. And it was really disheartening, and I wish I would have made that mistake. So just a little reason why they're so important. So the SI system, or the International System of Units, is also known as the metric system. If you didn't know, we in the United States of America do not use the metric system. We say things like miles, feet, inches, acre. These 4-letter words are not allowed in class. And it's going to take some getting used to. But there's also another country, Liberia and Western Africa. They do not use the International System of Units. They've actually adopted what we use in the United States. And then there's also a country, I'm going to move myself. It is Myanmar. And Myanmar also doesn't use the International System of Units. They've created another sort of system that they use. Again, just for your information, people who live here, like, what are the metrics? What is the metric system? So appropriate units to use. Okay, mass and weight. And I'm going to go through this pretty quickly. If we're talking about mass or weight, we want to use grams or kilograms. Distance, centimeters or meters, whatever is appropriate. Volume, millimeters, or liters. Volume is mostly going to be used for liquid. We're technically not going to measure length times width times height very often, but we're going to measure liquids a lot. And that's going to be really, really important to know to use milliliters and liters. Temperature, going to be a tough one. We cannot use Fahrenheit. I do not accept the F word in my class. That F word is Fahrenheit. We're going to use Celsius or Kelvin. This will probably be the hardest one for us to adapt to, but I promise once we do it a couple times, they'll be great. Time, we're only going to use seconds unless it's like thousands and thousands of seconds, then we can go to minutes, but we usually don't use hours. And then finally, a new term you guys will learn is density, which is grams per milliliter or grams per centimeter cubed. And we'll go into this a lot more in a week or two. Mass, length, and volume. Again, I'm going to give you the sort of definitions and what the international system suggests that we use. Mass is a measure of how much matter is in an object, okay? Mass is a common measurement for solids and liquids. How heavy is it? How big is it? How much of something is in there? And we're going to use grams or kilograms. A lot of the times you hear people say kilos, that's kilograms. And then we use this by using a scale or using a balance in order to find that. Length is a measurement that measures the extent of an object's greater dimension. So length is very simple. It's in terms of distance. And we usually use meters, centimeters, or kilometers or kilometers. And again, you can measure the length of something using a ruler, measuring some kind of distance as best as you can. And volume is the amount of three-dimensional space a substance occupies or an object occupies, and it's common for solids, liquids, and gases. And we use millimeters, liters, because they're mostly liquids. We can do it with solids, we can do it with gases, but we're gonna use liquids a lot. And then of course we use this, we figured this out using glassware that's labeled. Temperature. Temperature is a quantitative measure of how hot and cold something is. We use this for solids, liquids, and gases. And again, degrees, Celsius, or Kelvin, and I'll talk about Kelvin when we get there. We can use a thermometer to do this as well. Time, I looked up the definition of time because I was trying to explain it and I couldn't. But it's a measurable or measured period within a continuum that lacks spatial dimensions. Wow, take that in for a second. And we use seconds. We can use a timer or a clock to measure this. And then density is the mass of a substance per unit of volume. Again, we'll get to that because we have a whole lesson on density. And we use grams per milliliter or grams per centimeter cubed. And of course, we just divide the mass by its volume. Pretty simple. This is super, super important. Measurements can only be added and subtracted if they have the same unit. If two measurements have different units, you must use dimensional analysis to convert between units before combining them. For instance, if you measure something in centimeters, but something else is measured in meters, you would have to have the same unit there. Again, like if I say, how long are two cell phones, and one cell phone is measured in inches and one cell phone is measured in centimeters, we would have to convert to centimeters in order to get the final sort of length of two cell phones. Example, 400 centimeters plus 4 meters. We'd have to convert meters to centimeters or convert centimeters to meters in order to add these up, okay? The answer is 800 centimeters or 8 meters. Thank you. I heard about this little nickname I have. I'm going to own it. I'm very grateful for you all watching this. It is getting dark out here, and I will see you guys soon. Take care.